Okay, so in this video, we're going to move on to section 5.5, and we're not going to cover all the topics in 5.5. We'll cover just the important ones, okay? So we're probably going to skip product of sum and the power reduction formulas. We will cover the double angle formulas and the half angle formulas. Okay, so this video is on the double angle formulas. Again, there's really just three double angle formulas over here. Sine of 2 theta is 2 sine theta cosine theta. Again, where do all these formulas come from? They are on page 401 in your textbook if you're curious where they come from. In a normal class, I would probably derive these for you. Basically, to derive sine of 2 theta, you just use the sine sum formula. You would just split this up and you write sine parentheses theta plus theta, and then use your sine sum formula to arrive at this. Okay, so same thing with cosine of 2 theta. You use your cosine sum formula, and same thing for tangent. Just one thing I wanted to point out for your cosine double angle formula. It's cosine squared minus sine squared, and the way you get, notice there's three forms. The way you get form 2a and form 2b is basically you do a Pythagorean identity substitution. So to get 2 cosine squared minus 1, how do they get that? They substituted. If you remember, sine squared is the same thing as 1 minus cosine squared. They just plugged in parentheses 1 minus cosine squared to get this. And likewise, to get this form, they substituted 1 minus sine squared, right? If you plug in 1 minus sine squared, 1 minus sine squared minus sine squared will give you 1 minus 2 sine squared. Okay, so that's how they got forms 2a and b. That might be a little bit useful in, kind of figuring out how they get this and this. They just did a Pythagorean substitution either into this to get this or into sine squared to get this. Okay, so again, all the proofs are on page 401 if you're curious. Okay. All right, so I'm going to have two examples here in the beginning that involve solving equations. So we're going to solve the equation. We're going to find the general solution, and we're going to find the solution on the interval from 0 to 2 pi, non-inclusive for the 2 pi. So let's start with example 1a here. I have cosine double angle x is equal to negative cosine x. So on the last quiz, a lot of you guys try to cancel out variables, right? I believe it was question number, I believe it was the first problem on the solving equations. You're not allowed to cancel variables when you're solving equations because you lose solutions, and you also are not allowed to divide by 0. Okay, so don't try to do anything fancy by crossing off these x's. These x's are inside the argument, so you're not allowed to do anything like that. But what you can do is move the cosine x over, so let's do that. Okay, now that we moved it over, again, you can't factor out any cosine x over here. This is inside the argument, so don't try factoring. If you take a look, right, at your 2 or 3 forms of your double angle formulas, I want to substitute one of these, right? If I substitute the first one, I'm still going to have a sine square. I don't want that. My current equation has everything in terms of cosine. So form 2a would be the best, best form to substitute into this. Okay, so I'm going to substitute 2 cosine squared x minus 1 into here. 2 cosine squared x minus 1 plus cosine x is equal to 0. And you can kind of see why I picked it, right? Now everything is a quadratic in terms of one trig function. Let me just rewrite this. Right, and now I can solve, and hopefully I can factor this, right? And in the last quiz, right, if you're not able to factor, you can always use the quadratic formula, but this actually ends up being a nice factorable quadratic. So we're going to write 2 cosine of x minus 1. This guy right here is going to be cosine x, and this one will be a plus 1, okay? So negative cosine x, positive 2 cosine x, that gives you the middle term. You can solve for x now by using the 0 product rule and your unit circle, okay? So over here, I already set this equal to 0. Cosine x is equal to negative 1. Well, where is x? Where is the x value, negative 1? It's going to be at pi radians. And for part 1, I want to write the general solution. So I'm going to write plus 2 pi n. So there's part 1. And then over here, I'm going to get cosine of x is equal to 1/2. And cosine is positive in quadrants 1 and 4, right? The x value, or the radian measurement, such that the x value is 1/2, is going to be x is equal to pi over 3. In quadrant 1 and quadrant 4, it's going to be 5 pi over 3. Again, I'm going to add 2 pi n, 2 pi n. I'm not going to condense these solutions because pi over 3, 5 pi over 3, they have separate distances. Okay, so for part 1 of the problem, this would be the general solution to this equation. Now, once you have the general solution, right, it's easy to find the specific solution. I'm going to plug in n is equal to 0 over here. I'm just going to get pi over 3. That's within the interval of 0 to 2 pi. If I plug in 1, right, 2 pi plus pi over 3, that's going to be outside the interval, so I'm done with this. If I plug in 0 over here, I'm going to get 5 pi over 3. If I plug in 1, again, 2 pi plus 5 pi over 3, that's going to go outside my interval, so I'm done with this. Plug in 0 over here, you're going to get x is equal to pi. And if you plug in 1, right, you're going to get 3 pi, which you don't want. So your only solutions in the interval from 0 to 2 pi, right, are going to be pi over 3, 5 pi over 3, and pi. Okay, so someone might ask, oh, why don't you plug in -1? But if I plug in -1, I'm going to be outside the interval from 0 to 2 pi. Okay, all right, so this is actually a problem, part B. That's actually in your textbook. I believe it's number 17. Okay, so those of you who are watching the video, this will help you. Again, you are not allowed to divide anything inside the argument, so don't try to cross off x's, x is here, and then, oh, look, there's a 2 here, there's a 2 here, I'm going to factor out that 2. You can't factor anything inside the argument. Okay, so the first thing I'm going to do is move this term over. I'm going to get sine of 4x plus 2 sine of 2x. Okay, you could put parentheses there if you want. You don't have to. Sometimes I find it's easier to visualize. Okay, now comes the trick, right? It's like sine of 4x. I've never heard of a quadruple angle formula. Do I have to derive it? No, not quite. Sine of 4x is actually a multiple of sine of 2x, right? And so what you can do right now is rewrite this as sine of 2 times 2x. Okay, so I'll show you that extra line, right? Sine of 4x is 2 times 2x. That's the key step right here. Well, how does that help us? Well, remember I showed you guys the theta substitution? Why don't you call this guy right now theta and rewrite it as sine of 2 theta plus 2 sine of theta. Okay, so all I did over here was let theta equal 2x. Okay, now what? Now you remember your double angle formula, right? Sine of 2 theta, if you forgot, let's go back and look at our notes, is 2 sine theta cosine theta. So let's substitute 2 sine theta cosine of theta plus 2 sine theta is equal to 0. And now you can use your algebra skills by factoring out the GCF, right? I could factor out a 2 sine theta over here and then use the 0 product rule. Okay, so I'm going to have two terms. I'm going to set equal to 0, 2 sine theta equal to 0, or cosine of theta plus 1 is equal to 0. Sine theta is going to equal 0 over here, and then cosine of theta is going to equal -1. Okay, so if you solve for theta over here, you're going to get theta, like what angle is the y value 0? You're going to get 0, and of course, pi, right? What angle is the x value -1? And theta, of course, is going to equal pi, right? Okay, so for this one, right, we can condense the solution. Theta, the distance between 0 and pi is just pi radians, so you could just write 0 plus pi n, or you could just say theta is equal to pi n, right? 0 plus pi n is just pi n. Okay, now, is that it? That's the general solution. Now, remember, theta, right, we want everything in terms of x. Theta, we said, was 2x. So let's plug in 2x back into the equation. You're going to get x is equal to pi over 2n. So this will be the general solution for this guy right here. And same thing for this one, right? If I write the general solution for this only this value, it would be theta is equal to pi plus 2 pi n. There is no condensing over here. Substitute 2x back into the equation. You're going to get x is equal to pi over 2 plus pi n. Okay, so this will be the general solution for this equation. Okay, now if I want the specific equation on the interval from 0 to 2 pi, I just start plugging in n values, starting with 0. Okay, as long as I'm in the interval from 0 to 2 pi, I'm good to go. So you don't want to plug in -1, right? Because then negative pi over 2 will be outside the interval. So start with 0, you're going to get 0. N is equal to 1, you get pi over 2. N is equal to 2, you're going to get pi. N is equal to 3, you're going to get 3 pi over 2. And if I plug in, so we started 0, 1, 2, 3. If I plug in 4, right, 4 pi over 2 is 2 pi. 2 pi falls outside of the non-inclusive 2 pi interval. So I'm done. If you do the same thing over here, right, if you plug in n is 0, you'll get pi over 2. N is equal to 1. You're going to get 3 pi over 2. If you plug in 2 pi plus pi over 2, again, that falls outside the interval. So these are the specific solutions on the interval from 0 to 2 pi.